In this video, we will find what is V of t and I of t. So V is actually across the capacitor, and I is the current passing through the circuit. Okay, that means these three elements are in series only. So time domain representations we need, that is V of t and I of t. And if you see the input, it is a 10 cos of 40. So this is a AC signal. So whenever we need to work with this type of circuits with input AC, we need to use the phasor representation. And KCL, KVL, mesh analysis, nodal analysis, all these things we can able to apply on the circuit with AC representations. Okay. Now our first job is to draw the circuit in the phasor domain. Okay, that is what we need to do. So for that particular purpose, the resistor 5 ohms will be 5 ohms only, no change. But when you have the capacitor C, then we need to take its impedance, that is 1 by j omega c. 1 by j omega c. So in this case, the input is 10 cosine of 4t. What is the phasor representation of this one? 10 at an angle of 0 degrees with omega is equal to 4. General representation is Vm cos of omega t. We know already about this one. Vm cos of omega t plus phi. By comparing these two, you can understand that Vm is 10 and phi is 0. What about omega? That is 4. Now you know what is omega and what is C also. C they have given 0.1 farad. So what is the phasor representation of this one? 1 by j omega we have 4, and this C value is 0.1. 1 by j omega c I am writing. It is equal to j is actually root of minus 1, j square is minus 1, j cube is minus j power 4 is plus 1. So whenever you are dealing with 1 by j, you can take that is minus j. Okay, you can calculate that. So wherever 1 by j is there, I can use minus j, and it is 10 by 4, that is equal to minus j into, it is 2.5. Okay, so wherever capacitor is there, that is a value 0.1 farad. Now we can write in the phasor domain, that is minus j 2.5. With resistor 5, again with resistor 5 only, and supply 10 cos of 40 should be represented with 10 at an angle of 0. With all these values, I am going to redraw the circuit in the phasor representation, that is like this. It is 5 ohms only, and current I am representing with I dash, or some textbooks are representing with capital I. Then the capacitor in phasor representation, now it is minus j 2.5, and across this one we have V dash or V bar. Then the supply is to be represented with in phasor representation, that is 10 at an angle of 0. It is first step we have to do. Okay, when you want to work on the circuit with AC supply like 10 cos of 40, the first thing what you need to do is nothing but you need to redraw the diagram in the phasor representation. That is this one now. Now you can follow whatever your previous knowledge is there on the KCL, KVL, mesh analysis and nodal analysis. All those things you can apply on this particular circuit. That's it. Now what is our aim? We need to get V. Okay, that means V bar is to be calculated. It is like a series connection of the two impedances only. One is 5 ohms and second one is minus j 2.5. Okay, so in between these two, and the voltage 10 at an angle of 0 is divided, so we have to apply voltage division rule. So as per voltage division rule, the voltage across the capacitor is given by the total voltage 10 at an angle of 0 is multiplied with the impedance where you want to calculate the voltage, that is minus j 2.5, by addition of the two impedances, that is 5 minus j 2.5. Now you know how to solve this one. We have already seen in our previous video, that is the multiplication, okay, should be done in between two polar representation of the complex numbers, and division is to be done in between two polar representation represented complex numbers, and addition and subtraction is to be done for the rectangular representation of the complex numbers. Now I'm rewriting this one. 10 at an angle of 0 is one complex quantity, and here what we have, like 0 minus j 2.5. This minus j 2.5 I can able to represent in the rectangular representation like this. By again we have another rectangular representation, that is 5 minus j 2.5. This is what we have. Okay. Now it is required to convert this j minus j 2.5 into the polar representation. Okay, like that we have to convert. For that, what I will do is it is equal to 10 at an angle of 0. It is, if you take the magnitude, you will get 2.5 only, and it is at an angle of, it is tan inverse of minus 2.5 by 0 will get. Okay, so like that you can able to convert all these things. Okay, tan inverse of minus 2.5 by 0 by this 5 minus j 2.5 can also be converted into polar representation like this, that is 5 square plus 2.5 square at an angle of tan inverse of minus 2.5 by 5. Okay, so if you can able to perform this one, what will you get is p value will be 4.47 at an angle of minus 63.43. This is what you need to occur. Okay. So when you know V of t in the, when you know V in the phasor representation, how to write this one in the rectangular representation? This is also important. Okay. It is the peak value. It is the phase phi. If you consider like that, now V of t is equal to 4.47 cosine of omega t, that is 4t minus 63.43 degrees. Finally, you have to write again in the time representation. Okay, solving in the phasor, but finally we are writing in the time representation only. Now another quantity we have to calculate, that is I of t. So it is also as per it is just a simple series connection of resistor and capacitor. So I in phasor is given by resistance by total impedance we have to take, sorry, voltage by total impedance we have to take, that is 10 at an angle of 0 voltage is there, then 5 minus j 2.5, very simple thing. Okay, so like this we can able to calculate. So and you can able to continue like this, or you can rationalize this one. Rationalize is nothing but 10 at an angle of 0 by 5 minus j 2.5. We need to multiply with complex conjugate of 5 minus j 2.5, that is 5 plus j 2.5 by 5 plus j 2.5. These two will be cancelled, no change in the equation. Okay, now it is equal to, what can you write in the sense here, the denominator I am writing now, you need to convert this 5 plus j 2.5 into polar form actually. 5 plus j 2.5 by, this is like a minus b, this is like a plus b, resultant will be a square minus b square. Okay, so if you perform that one, 5 square minus b is nothing but j 2.5. So j square is minus 1, minus minus will be plus. You need to take care of that one. Then finally you will get 1.789 at an angle of 26.57 degrees. Okay, then how to write this one in the time representation now? It is a peak value, 1.789 is the peak value, and phase is 26.57. So 1.789 cosine of 4t plus 26.57 degrees. Like this. This is a way of calculating the currents and voltages using some Ohm's law or voltage division rule. In this particular problem we have used both of them. So what is to be remembered in the sense, you need to first convert the circuit into phasor representation, then perform whatever you want like KCL, KVL, nodal mesh analysis, and then finally you can able to write in the time domain representation. Okay.